Assalamualaikum warahmatullahi wabarakatuh. So for today, we are from Group B2. Would like to present about Petroleum Refinery Plant for CHE 223 Fluid Mechanics. So our team members consist of me, Haziq Irsyadi, Aimanuddin, Amira Atirah, and Syafiqah Balkis. So, without wasting any time, let's take a look at the introduction. Okay, a petroleum refinery plant is an industrial facility that processes crude oil into valuable products such as gasoline, diesel, jet fuel, and lubricants. The refining process involves physical and chemical transformations, including distillation, cracking, reforming, and treatment to separate and enhance different hydrocarbon fractions. In petroleum refinery plant, we have a cooling system. Cooling systems play a vital role in refinery operations by dissipating excess heat generated during various chemical processes. Efficient cooling ensures optimal equipment performance, prevents overheating, and enhances safety. So, what are the importance and challenges of water distribution in a petroleum refinery plant? For the importance, number one is cooling and temperature control. Water is used to cool equipment and processes, preventing overheating and ensuring safe operations. And then, process support. Water is essential for many refinery processes, such as cleaning, heating, and chemical reactions. And then, for steam production, refineries use water to produce steam for power generation and heating. Also, for safety systems, water is crucial for fire suppression systems and emergency cooling. And the last one is regulatory compliance. Water distribution systems help refineries meet environmental regulations related to water use and waste. What about the challenges? For challenges, the water availability, refineries often face issues with limited water supply, especially in dry regions. Also, contaminated or hard water can damage equipment and affect operations. That's why water quality is also one of the challenges in this water distribution. For maintenance and fouling, water system can suffer from clogging and mineral build-up, which reduce efficiency and increase maintenance costs. Also, water can lead to corrosion. Corrosive water can damage pipes and equipment, leading to failures of the process. Energy consumption, water treatment and distribution requires significant energy, which adds to operational costs. And the last one is climate variability. Extreme weather conditions like droughts can affect the availability and quality of water. Let's move to our solution. So, for this project's objectives is to design an efficient and sustainable water distribution network for a petroleum refinery plant using fluid mechanics principles. So, the key findings for this project is cooling tower, heat exchangers, and air-cooled systems help regulate temperature and prevent overheating of equipment. Improper cooling can lead to process inefficiencies, equipment damage, and increased energy consumption. So the contributions of this water distribution system provides an optimized approach for designing water distribution networks in refineries, and we would like to improve cooling efficiency by recommending suitable cooling systems and flow control mechanisms.
So, this is our industrial water distribution network layout diagram. Our design used one outlet, which is the centrifugal pump, and connected with three branches, which is cooling system, steam generation, and process equipment. We use 90-degree elbows and teeth as fittings of our design. We also use a variety type of valve, which is control valve for cooling system, ball valve for steam generation, and butterfly valve for process equipment. The flow rate requirement for cooling system is 1,500 liter per minute, for process equipment 300 liter per minute, and for steam generation 500 liter per minute. So this is the advantage and disadvantage of our design. The advantage of our design based on the efficiency is a single pipeline will be more efficient as it prevents the energy loss due to friction. Second is the type of the carbon steel pipe are more efficient because it more stronger and durable. However, the disadvantage of our design based on efficiency is destruction in water supply if any damage occurs to the pipeline routes where need a high maintenance to repair or replace the equipment. Next is the type of carbon steel have potential to be corrosion, especially in aggressive environments. Next is the advantage of our design based on cost effectiveness, where there are only one main equipment used that can prevent the cost of the plant equipment requirement. Second, the water flow from main tank in one pipeline directly, where can reduce the need of multiple pumping stations along the route. However, the disadvantage of our design based on cost effectiveness is if the main pipeline got damaged, it need high maintenance to recover the whole equipment. Lastly is the advantage of our design based on pressure management. So, as our design consists of an elevation that have a higher pressure, it can influence the flow rate of the fluid directly and have potential for a better control. However, the disadvantage of our design is higher pressure drop due to the bend and fittings such as occur head loss and increase the operational challenge.
Alright, now for the calculation, to find the velocity, we are going to use the Torres reservoir, where the equation is V equals to 2GH square root, where the H is the surface water to the outlet. And so for this, we take the outlet height, which is 4 meters, and the main tank is equals to 7 meters. And then we put in the equation and we got 10.85 meter per second for the velocity. Alright, now we're going to find the Reynolds number. We're going to use the equation is RE equals to rho VD over dynamic velocity. Alright, for this we are going to use rho equals to 1000 kg per cubic meter, and V we got it just now, 10.85 millimeter per second. For D we take the 12 inches and then we convert it to meter, which is 0.3048. And then viscosity of water, we take the natural one, which is at 20 degrees Celsius, that is 0.001002 kilogram meter a second. And then we put it on the equation and we got 330479.042 for the Reynolds number, which is the turbulent flow. Next up, we're going to find the friction by using relative roughness and Murray charts. So first, for the Murray chart, we have to refer to our Reynolds number and relative roughness. So our Reynolds number, we just get it just now. And then for relative roughness, we have to use the surface roughness, that is 0.0015 over the diameter, that is 0.3048, and the answer we got is 0.00492. And then after referring the mood charts, you get the friction is equals to 0.029. Alright, now to find major loss, you have to use the F. Major loss equals to F L over diameter and PV2 over 2 over specific gravity. So and then we just put the information we got, and for the outlet 1 we get 16.56, for outlet 2 we get 10.28, and for outlet 3 we get 4. Alright, now for the minor loss, we have to take the equation, that is H minor loss equals to K, which is K is the coefficient, and V in bracket V2 over 2G. Right, and then we just put the information. We get outlet 1 is equals to 11.16, outlet 2 is 10.80, and also outlet 3 is also 10.80. Alright, so next we're going to find the pump pressure head. So for this calculation, we count for every outlet. So for outlet 1, we will discard that doesn't have information. For outlet 1, we discard pressure 1, pressure 2, and also V2. And then after that, we get our equation, Z2 plus H major plus H minor minus V12 over 2G minus Z1. And then we just put information that we have. We get the answer for outlet 1 is 21.71. Right, now for the pressure outlet number 2, we have to discard pressure 1, Z1, pressure 2, and also V2. Right, so we just put information, that is Z2 plus H major plus H minor minus V12 over 2G. And then we put the information that we have. For outlet 2, we got 23.08. Okay, now for the outlet 3, we will discard the pressure 1, Z1, pressure 2, V2, and also Z2. And we have H major plus H minor minus V12 over 2G. And we put up the information, we get the pump pressure head for outlet 3 is 8.8 meter. Now for the last calculation, we're going to find the total head loss, where we're using head loss equals to delta H major and plus delta H minor. So we put the information that we have, and then we plus it all, we got 63.6 meter.
So for our pipe sizing, material and internal pressure, we have choose the best specification for our pipe, which is for sizing. The minimum size of our pipe is 12 inches. For internal pressure is 140 kilopascal. So this pressure can flow in this pipe and may vary depends on the size of the pipe. For material, we choose carbon steel pipe because the material are usually used to flow the water, and due to resistance for high pressure and prevent corrosion.
For the significance of pipeline routes, for the type of pipe, we use carbon steel pipe rather than PVC because it's more stronger and more durable, and it resistant to corrosion as our plants consist of crude oil. Our pipe sizing is a constant, which is 12 inches. For the efficiency of pipeline routes, we can reduce the friction as it has a direct flow and less of bends, and the elevation helps to prevent the pressure loss as with the help of the gravity. Lastly is the cost effectiveness. A single pipeline and short route consists less of maintenance requirement. For significance of the fittings, we use 90-degree elbows to alter the flow direction of the pipeline system. Next, we use centrifugal pump as transport of the fluids to move easily through the pipe and speed up the process. We also use temperature indicator to measure and detect the temperature of the substance, and we use flow indicator to display the rate of the fluid flow through the pipe. We use a variety type of valve. First, we use control valve for cooling process to ensure automatic balancing of the cooling water system because the valve use only as much water as the cooler requires. Next is bore valve for steam generation because of its quick and reliable shut-off capability. Lastly is butterfly valve for process equipment because of its high pressure recovery and low pressure drop and superior flow isolation. For the pump requirement, pump is essential for design because it is a mechanism that used to move crude oil of petroleum refinery plants, and it used to make the crude oil flow more easily through the pipe through and thus speed up the refinery process. The pump purpose is to maintaining the pressure and the flow rate to make the flow process of the plant constantly smooth. And the consideration of the pump is the flow requirement, the distance and elevation, and the maintenance that require where it based on the design. So pump facilitate water movement by lifting the water to keep the water flowing and ensure a continuous water supply to the equipment. So this is the comparison of pump with different types are shown as in the table, which is centrifugal pump and positive displacement pump. For performance curve, centrifugal pump as flow increase, pressure heat decrease. For positive displacement pump, flow rate is more directly proportional to pump speed. For pump cavitation, in centrifugal pump, more prone to cavitation. In positive displacement pump, less prone to cavitation. For NPSH, for centrifugal pumps, have specific NPSH requirement to avoid cavitation, and for positive displacement pump, have lower NPNH requirement in avoid cavitation, and for the efficiency, in centrifugal pump, tend to decrease at lower flow rates, and for positive displacement pump, less affected by change in flow. For the working principle of centrifugal pump work by using a rotating impeller to convert kinetic energy to a fluid, and centrifugal pump is a mechanical device that moves fluid by transferring rotational energy from one or more driven rotors called impellers. So this is the simple step that consists in centrifugal pump, where it starts with the fluid enter the impeller along the impeller shaft and flows out along the circumference between the blades. Next, it goes to the rotational motion of the impeller accelerates the fluid through the impeller vanes and into the pump casing. In the worm casing, the impeller is offset, effectively creating a curved funnel with a cross-sectional area that increases toward the pump outlet. And last is the asymmetry of the worm housing design can lead to greater wear on the impeller and drive shaft.
Okay, next is for safety measures for industrial application. So the first question is, in the context of industrial application, how will the proposed safety measures address potential issues like water hammer and pipe burst? So the first one is proper pipe sizing and layout, because to ensuring the pipe are correctly sized and laid out with adequate support minimize the chance of pressure fluctuation. The next one is pressure relief valve, which is it can help pressure relief valve release excess pressure in the system to prevent sudden surge that can cause hot water hammer or pipe burst. So the impact of pressure relief valve is by controlling pressure spikes, they can reduce the stress on pipes and fittings. So the next one is regular maintenance and monitoring. So how can it help us? So the routine inspection and real-time monitoring via sensors can identify pressure irregularities early. So the impact is prompt corrective action can prevent issues before they escalate into pipe burst. So the last one is pump control system. How can it help us? Soft start and variable frequency drive (VFD) system regulate pump speed, avoiding sudden pressure increase during startup or shutdown. So the impact is gradual pressure adjustment, reduced strain on the piping network. So the next slide, which is the next question, is can you provide specific examples of how pressure relief valve and surge protection device will enhance safety in an industrial setting? So for the pressure relief valve, the first one is steam power plants. So PRV roles here to install on the boiler and steam line to release excess steam to maintain safe pressure levels. The consequence without pressure relief valve here is it could be overpressure and rupture the boiler drum or steam piping, resulting in catastrophic explosion. So the impact here, it can prevent system failure, ensure uninterrupted power generation, and protect plants personnel. The next one is ammonia refrigeration system, which is PRV role here is PRV on the compressor and also pipeline release excess ammonia to a safe area or recovery system. The consequence without PRV here is to excess pressure could rupture pipes, leading to ammonia leaks that are toxic and flammable. The impact here is to prevent leaks, ensure compliance with safety standards, and protect workers and equipment. The last one is oil refinery distillation units. So for the oil refineries operate with high temperature crude oil processing that involve extreme pressure condition. If pressure surge beyond safe levels, it can lead to equipment failure, fire hazard, and also explosion. The next example is water hammer. The first one is shockwave absorption. The diagram in the image shows how a piston inside an air chamber absorbs the shockwave. When a quick valve closure occurs, it creates a sudden spike in pressure, but the arrestor absorbs and dissipates this shock, preventing damage. So the next one is optimizing valve closure. The image emphasizes the importance of regulating valve closure speed. When the valves are shut too quickly, the water momentum slams against the closed valve, creating the water hammer effect. By optimizing how valve close, pressure surge are minimized, ensuring smoother operation. The last one is longevity of equipment. The inclusion of a water hammer arrestor help increase the lifespan of pipelines, valve, and fitting. By controlling hydraulic shocks, less stress is put on system components, reducing wear and tear over time. So for the next slide is environmental impact assessment for industrial application. The question is, in the context of industrial application, how do you anticipate the environmental benefits of the design to manifest? Are there specific ways in which the design will contribute to more sustainable resource usage and reduce environmental impact within these industries? So water conservation in industrial application is a crucial aspect of environmental impact assessment in industries. Water is usually used for cooling process. So the first one is core design aspect. Industrial process should incorporate water conservation measure from the initial design phase to ensure efficient usage. The next one is sustainable water usage. Industries must implement strategies to use water responsibly, reducing waste and optimizing consumption. The third one is prolonged water usage. Using and recycling water in industrial operation helps extend its usability and minimize freshwater demands. The fourth one is design for water sustainability. Infrastructure should be designed to integrate water saving in technologies such as rainwater harvesting, closed loop cooling system, and also wastewater treatment. And the last one is industry water conservation. Companies should adopt water efficient practice, invest in modern equipment, and comply with regulation to reduce their environmental footprint. The next slide is integration of sustainable practice in industrial application. The first question is, could you provide example of energy efficient pumping practice that will align with the demands of industrial operation? How might the incorporation of such practice impact overall energy consumption and operational costs within industrial facilities? So the first one is efficient pumping system design. So designing system with a minimal friction losses such as reducing pipe bands and using larger diameter pipes where feasible. The next one is use of renewable energy sources. For example, powering pumps using solar or wind energy where feasible, particularly in remote areas or for irrigation system. For the last slide, the second question for the integration of sustainable practice in industrial application. So the question is, when promoting sustainability and responsible water usage within the industrial sectors, how do you plan to engage stakeholders and foster a culture of environmental awareness? Are there any challenges anticipated in implementing sustainable practice within industrial context? So the first one is stakeholder engagement. We can do a workshop and training. For example, we conduct a session to educate employees and the management about the importance of sustainability and efficient water usage. The next one is collaboration with supplier. We can do a partner with a supplier who prioritize sustainable practice to reinforce a shared commitment. The last one is customer awareness. We can communicate sustainability effort to customer to build trust and enhance brand reputation. The next point is incentive for sustainability. We can offer rewards or recognition for employees who implement or innovate sustainable solution. We also can leverage government grants or incentive for adapting green technologies. I think that's all from us. Thank you.